Good morning and welcome to this first lecture on engineering mechanics. Before we go into the lecture itself, let us briefly see what are the learning outcomes from this lecture. We'll try to see what engineering is, what mechanics is, and then put together we'll see what engineering mechanics is. And then we'll see a few applications of engineering mechanics as we see them in day-to-day life, followed by classification scheme of engineering mechanics, fundamental quantities that we use in the subject and their units. So to begin with, let us see what engineering mechanics is all about. It is made up of two words, engineering and mechanics. So let us just try to see what this word engineering means. This word stems from two Latin roots. Ingeniare means to devise and ingenium means cleverness. So seen that way, engineering is all about devising clever machines for human comfort and safety. The other word, mechanics, refers to the study of movements of objects and the forces causing these movements. Put together, engineering mechanics is the study of movements of objects and forces causing them with a view to devise machines for human comfort and safety. Having seen what this engineering mechanics is all about, let us see a few examples of machines that use engineering mechanics. The one shown here is a water wheel. You can see that the force of the jet of water causes the wheel to turn. That is, you have force and movement. This is one classic example of a device that resulted from the study of engineering mechanics. The second one, which is a forerunner of the present day bicycle, as you see here, again involves force of pedaling and movement of the bicycle wheels and thus the bicycle itself. And the third application is that of a hand pump. You have force applied at the end of this long handle, which results in water being drawn from a bore well. Having seen these applications, we'll try to see the classification scheme of engineering mechanics. In this classification scheme, one branch of engineering mechanics, which we call rigid body mechanics, refers to the subject where we assume that objects do not deform however large the forces may be. Then a second branch is what we call deformable body mechanics. This branch is also commonly referred to as solid mechanics or strength of materials, wherein our interest is in finding what deformations result when a given force is applied or what force should be applied to result in a given deformation. The third branch of the engineering mechanics is what we may call fluid mechanics, which deals with liquids and gases. All through our course we study rigid body mechanics. That is, we'll assume that objects do not deform however large the forces may be. Yet another classification of engineering mechanics, wherein we can see statics as one branch of engineering mechanics. In statics, the systems of objects that we consider are under equilibrium. By equilibrium we mean either moving with constant velocity or not moving at all. Another branch, dynamics, involves systems which are not in equilibrium, that is, systems which are accelerating. Again, this dynamics can be split into two branches, kinematics and kinetics. In kinematics, our focus is only on the movements and we are not concerned with forces that are causing the movements, whereas in kinetics we are interested both in the movements and the forces causing them. During this course we'll be studying about statics, we'll be studying about kinematics, we'll be studying about kinetics. Yet another classification scheme, a scheme given to keep generality in picture, In this scheme, relativistic mechanics is one branch wherein we deal with very large objects moving at very large velocities. That is one end of the spectrum. Another end of the spectrum is quantum mechanics, wherein we deal with very small objects, perhaps atomic scale or even lesser. And engineering mechanics, which is midway between these two, wherein we study day-to-day problems that we come across in field. In our course, we are interested only in this midway path. Having seen all these, we'll try to see what are the fundamental quantities with which we are involved. One is mass, which indicates amount of substance. The second is the distance, which is a measure of dimension, size of the body, how big or small. And the third is measure of duration, whether the event occurred very quickly or very slowly. Wherever we go in universe, we'll find one of these, either mass or distance or time. See, that way we may call these as trinity of fundamental quantities. It is interesting to note that each of these quantities themselves may come in three forms: mass either as a solid or liquid or gas, distance either length, width and height, time present, past and future. Okay, whatever be the phase of the mass, we try to measure it in either kilograms or grams. Again, distance in either direction we measure in kilometers or meters, and time in seconds or hours. When we use kilogram, mass and second as the units, we are using SI unit system, international units. We'll try to see more of these fundamental quantities and derived quantities as we go on into the further units. With that, we conclude this lectures and we present the summary as we saw that engineering mechanics is the study of movements of objects and forces causing them with a view to devise machines for human comfort and safety. And then we saw several applications of engineering mechanics in day-to-day life. We saw three in specific, but if you look around, you will find many such examples. And third, all through this course we'll consider objects to be rigid, that is, they do not deform however large the forces may be. And we saw three fundamental quantities, that is mass, distance and time, the units being kilograms for mass, meters for distance and seconds for time. That's all for this lecture. Thank you.